And we are going to figure out how to graph and sort of write out steps for graphing anything that's either sine or cos. I'll write sine here. If you have all of these transformations at once. So you have a horizontal stretch and compression, vertical stretch and compression, horizontal translation, and horizontal or vertical translation. What is the order that we're going to do this? Now, like I said, in our transformations unit, we went from left to right. And if you want to do that for this, that works as well. The problem is with sine and cosine graph, you have 5 points. You have the one starting on the center line, then the maximum, center line again, minimum, then center line again. And so there's a lot of calculations you need to do. This is a shortcut. It's still not going to be super fast, but it's going to be faster than doing that. And what we're going to do is we're going to think about the patterns that we saw in our graphing up till now and then use that to graph everything together. The first thing that we saw is the only thing that changed our center line, because our center line started on the x-axis, was our d value. So when we go to graph this, we're actually going to start by graphing our center line or our sinusoidal axes. So it's kind of really backwards because we worked from left to right and now we're starting with the thing that's on the farthest to the right. After graphing our sinusoidal axes, we're going to look at our A value because our A value is our amplitude, and we can use our amplitude and our center line to find our maximum and minimum. So in the example we did before, in the very last one where there was a -3, we had a -3 as our d value and a half for our amplitude. And we could use that to find out that it went up to -2.5 and down to -3.5. So we can easily find our maximum and minimum using our center line and our amplitude. The next thing we're going to do is we're going to use our B value to find our period. And remember that our period is always 2 pi divided by our B value for our sine and cosine graphs. We're going to label our period and divide it into 4 equal sections. Just like we've done all along, we find our period, which was normally 2 pi, divided into 4 equal sections to represent the 4 quadrants. We're going to do the same thing here. At this point, even though we haven't done the C value yet, we're going to graph things. We're going to draw a temporary graph of what it looks like, and then we're going to look at our C value. So we'll graph it with probably a dotted line because it won't be our final graph, and then our C value is just a shift left or right, so then we're going to graph it again with the translation. So I think this has a catchy, it's easy to remember because it's sort of a catchy name, DAB C. So you do the DAB first and then you do the C. Football players will like that, I guess. And we're going to start with the D value, then the A, then the B value. And we'll do an example right now just to get a sense of how this works. Okay, so let's graph y equals 3 cos 3 cos 2x minus pi over 4 plus 1. So this is in the proper form. Our horizontal compression is already factored out, so we don't have to worry about that. So when we're going through our graph and we go to graph this, the first thing we're going to start with is our d value. Our y-axis. Here's our x-axis. Our d value is 1. So we go up 1, and we draw our sinusoidal axis at y equals 1. Pretty straightforward. Our a value, our amplitude, is 3. So when we get to our a value, we're going to use our amplitude to find our maximum and our minimum. Since our amplitude is 3, we're going to go up 3 all the way up to 4. That'll be our maximum. And we're going to go down 3 from our center line, which will go down to -2. That's going to be our minimum. Our period, our b value, tells us our period. And our period is always, for sine and cos, 2 pi divided by our b value. Since our b value is 2, our period in this case is going to be pi. Choose somewhere along your x-axis to mark 1 period, and then divide it into 4 equal sections. So half will be pi over 2. Half of pi over 2 is pi over 4. So it'll be 1, 2, 3 pi over 4. Once you've done the DAB, then graph it temporarily. So where does cos normally start? Cos normally starts at a maximum. So start at your maximum, then go to your center line, down to your minimum, back to your center line, and back to your maximum. I'm just going to draw this in a dotted line because this is not our final graph. This is our graph before our horizontal translation. And then once you've got your graph, now we look and our c value is minus pi over 4. That means that you're going to shift things pi over 4 to the right. So we take each of those 5 points that was forming our cos graph, and we shift them pi over 4 to the right. The nice thing about our axes is you can see that pi over 4 is already labeled. So we know that this point has to go this far. This one needs to go over there. And now we've graphed it completely. So we start with our center line, then use our amplitude to find our max and our min values, use our b value to find our period, divide it into 4 equal sections, and then graph things. And since it was a cos graph, it starts at a maximum. And then finally, once you've done that temporary graph, draw the final graph by just shifting all 5 of those points either left or right as needed. So one final little note to put here at the bottom. We did a cos graph. Cos graph starts at a maximum. What would you do if there was a negative in front? That would be a flip over the x-axis, right? So if a cos graph normally starts at a maximum, if you had a negative cos graph, it would start at a minimum. Where does a sine graph normally start? Starts on your middle or your center line. Going up, right? So a sine graph normally starts on your center line or your sinusoidal axis going up. So a negative sine graph starts on your center line going down. So now we can use this technique 2 ways to graph anything we want, and that's what we're going to do next. And also, if you have any graph, you can take the graph and work backwards and find the equation.